Why does ice always melt? And why does coffee always cool down? Why does the battery of my mobile always decrease? Why do things happen one way and not the other way around? The answer to this is rather a perplexing concept that is elementary to the universe and crucial to understand. Entropy. Entropy is often described as the measure of disorder of a system. This definition is quite misleading. To understand more, let's take an example. Imagine this is a container half full of gas. Now if we remove this barrier, the gas expands to occupy the full volume of the container. We can say that the entropy of the gas is increased. Why more entropy? Just because there are more ways for the gas particles to arrange themselves and to be more disordered. And these different possible arrangements of the particles are called as microstates. This insight was given us by Ludwig Boltzmann. He described entropy as the number of microstates of particles in a system. The second law of thermodynamics says that entropy in a closed system would always increase, but this doesn't tell us why entropy actually increases. Entropy increases because there are more ways for the particles to arrange themselves in the future rather than in the past. Yes, this is a pretty complex statement. Think of it this way. There are more ways for the chess pieces to arrange themselves in between of the game rather than at start of the game.
And the probability of the chess pieces arranging themselves in a higher entropy state or a more disordered state is much bigger than the probability of the chess pieces arranging themselves in a lower entropy or a less disordered state. To give you an idea of this probability, let's bring back the box filled with gas. In all of the trillions of microstates possible for these gas particles, there is one where all gas particles spontaneously arrange themselves, filling half of the container and thereby decreasing entropy. But the odds of this occurring is 1 in 10 to the power 150 trillion billion.
Thus, the probability of lower entropy arrangement is so absurdly small that it never happens, and entropy always increases. This applies to the universe too. The universe at the time of its formation was at the lowest entropy state possible and had nowhere else to go except a higher entropy state. So the universe started on an inexorable path for more and more entropy, more and more disorder. And all of the work done by entities residing in the universe, whether the disorderliness of my room or the rotation of the Saturn's moon, everything contributes to the increasing entropy of the universe. Even we are a result of increasing entropy. All biological processes, physical phenomena, nature, thought, and even memory is a consequence of the second law. But there's a dark side too. From now, trillions and trillions of years later, the universe would reach a state of thermal equilibrium, means that there would be perfect distribution of mass and energy. Entropy would stop increasing anymore as there would be no free heat or energy to sustain any of the life processes. And the worst consequence of this would be that it would wipe out all of the life in the universe entirely.